Okay, welcome to the Livestock Selection or Genetic Selection lecture. This will be from chapter 13 in your text. Okay, so let's begin. Okay, genetic decisions in production agriculture. Okay, there's different market signals, I guess, indicating price favoring one type over another. This is obvious when you go to sell a group of calves if they're all black or if they're a multitude of different colors, typically, and all black or a group that is all one color is going to bring more money than a mixed color group. And again, your goal in production ag is obviously to make as much money as you can off of what you're producing. So again, market signals will kind of indicate different price favorings. Okay, environmental constraints make one genotype and phenotype more suitable maybe to one area over another. Like our cattle are probably going to be a little bit different than somebody raising cattle in Texas. Okay, and then there are different trends or things just like preferences, for people, in the grocery store or in fashion or something like that. There's different trends and kind of fads that happen that maybe make you to cause different decisions for production agriculture. And then natural selection allowing more fertile and vigorous animals to thrive under certain conditions. Okay, if we talk about breeds, populations of animals that share a distinct set of characteristics, and they were established by a deliberate selection to fix these traits to be carried through the generations. Okay, so that's where the different breeds became prevalent, or different breeding associations kind of came about. It's because they identified features in certain animals that they liked, that they wanted to try to keep as pure as possible, or kind of keep more accurate records of those. Okay, and it was done to suit different preferences within the species. Okay, and as we go through our different species later in the semester of like sheep, goats, swine, beef, dairy, all those different ones, we're going to talk exclusively about the different breeds and what makes certain breeds more desirable, or kind of what each breed brings to that animal group. Okay, but you can see down here at the bottom, if you talk about at the very top, you have that elite seed stock, down to the multiplier seed stock, commercial producer, and then finally the growing and feeding. Okay, these are going to be AI type studs. We talked about AI, and we'll talk about a little bit about EPDs and stuff like that. Semen providers in the different industries. Okay, that's going to be these guys up here. Okay, then you're going to get down to the multiplier seed stock. These might be your local bull producers that you might buy your bulls from for your operation. Okay, or local stallions that you might breed your mares to, or something like that. Okay. Then you get down to the commercial producers, which are going to be, again, your kind of everyday guys, or more of the local people that you see that maybe don't have bull or female sales, but their primary generator of profit is going to be selling that offspring. And then finally, the growing and feeding enterprises down there at the bottom are the finishing stages. Okay. A few terms for this section. We have quantitative traits and qualitative traits. Okay, quantitative traits are going to be referred to something that can be objectively measured. Okay, or like a number. Okay, such as birth weight, frame score, body condition score, rate of gain. Those are all quantitative traits that you can actually calculate and put a number associated with them. These qualitative traits, or the quality, is going to be something that's descriptive or a subjectively measured thing, like what color is the animal, do they have horns, kind of how are their feet and leg structures, stuff like that. Okay, it's not really a numerical value, it's more of a subjectively measured type thing. Then we talk about phenotype and genotype. Okay, phenotype, remember, is going to be that exterior appearance. Genotype is going to be that genetic makeup of the animal. Okay, I think we touched on this maybe in the lecture previous. Okay, so just remember that genotype is going to be their genetic makeup. Phenotype is going to be that actual physical appearance. Okay, So something that's important to remember with genetic decisions and genetic livestock selection is you have to try to remove as much of the external or environmental influence as possible on the records, okay? So this is going to be important for like bull selection, or even female selection if you're trying to buy some elite females from somebody's sale, okay? An example of this, again, referring back to the cattle industry, is what's called a 205-day weight, okay? And it's basically an adjusted weaning weight, okay? So what they do is they take the actual weaning weight minus the birth weight divided by the day and ages at weaning, and that'll get their average daily gain for every day that they were born, okay? Then it takes that average daily gain times 205 to put all of the animals on the same scale, add back in the birth weight, and then there's this age of the dam adjustment, okay? And you end up with an adjusted 205-day weight. So what this is doing is it's trying to take out the variable of when these calves are born. So say you're comparing two bulls and you're trying to decide which one you'd like. If there's an adjusted 205-day weight, you can say if these bulls were born on the exact same day and they were weaned on the exact same day at 205 days of age, these bulls would weigh this much, you know, and you could say this bull weighed more and this bull weighed less, okay? So if we work through an example, okay, we'll refer back to this. This is going to be this age of the dam adjustment factor. Okay, so if we have an example here, okay, our first calf, and this is going to be comparing a bull calf to a heifer calf, so maybe not apples to apples, but it'll give you an idea of what the purpose is, okay? So the weaning weight of this calf is 540 pounds, birth weight 82, and it's a 190-day-old bull calf from a 4-year-old dam. Okay, so what we want to do here is we want to do 540 minus 82, okay? And if you do that calculation, then it's going to be divided by 190 days, okay? So what that's doing is it's showing your weaning weight of 540 minus the birth weight, okay? So that's going to be the total pounds that it has gained in its lifetime, divided by 190 days old. So this calf gained 2.41 pounds per day, okay, of its lifetime, pounds per day, okay? So from there, then you can take your average daily gain times 205, because you're wanting to put it on that same 205-day scale or get it to the exact same. Add back in the birth weight and then add back in that factor. Okay, so we have a bull calf from a 4-year-old dam. If we look at our little chart here, okay, if the dam is 4 years old and it's a bull calf, it's 20 pounds. So this calf would get a 20-pound adjustment, is equal to this calf, if it was weaned at 205 days, would weigh about 596 pounds at 205 days old. Okay, so if we work through another one, we're going to have 525 minus the birth weight of 70 pounds divided by how many days old it is, 180 days, is equal to this calf gained 2.53 pounds per day that it was alive. Okay, then you're going to take that gain times 205, because again you're wanting to put it on the same day length, the same day of age. Add back in the birth weight of 70 pounds plus your factor. We have a heifer calf born to a 2-year-old dam. So if the dam is 2 years old and it's a heifer calf or a female calf, we get to add in 54 pounds for this calf, plus 54. And if you do that calculation, you're going to end up with 643 pounds at 205 days old. Okay? So actually, even though this calf weighed a little bit less, okay, and it was younger, okay, its mother, okay, this 2-year-old dam, actually did a better job of raising this calf than this calf did, okay, even though this one weighed heavier, 540 versus 525, okay. So actually, if you're going to pick between those two, if you're looking at the ability of the dam to raise a calf, this dam is actually going to, kind of be superior to this one, okay. I will ask you to do one of those calculations on the quiz, so kind of work through a couple more examples, and I'll probably have a couple on our lab assignment for this section. Okay, so that's just one, and remember the reason for that is because you're trying to take out the environmental influence on those animals. Okay, the next idea we'll talk about is heritability, and I know that we've talked about heritability a little bit, okay, but heritability it estimates or it describes the percent of total phenotypic variation that is due to a breeding value, the amount of selection that's passed from parent to offspring, okay. A trait that is highly heritable will be 40%. So how much of that trait going from the parent to the offspring, how influential is that going to be? High heritability is over 40. Low heritability is less than 20. Okay, so your book has a huge table, okay, table 13.4, and this is just one species. This is just the beef species out of that chart. Make sure and look at the chart for the rest of the species, okay? So what this chart is saying is it's saying anything over 40% is a highly heritable trait that can be passed from the parent to the offspring. Okay, so anything from weight at puberty, scrotal circumference, birth weight, gestation length, these are all very highly heritable traits. Mature weight, carcass quality grade, yearling weight, tenderness of meat, those are all highly heritable. Okay, you look down at the lowly heritable, calving interval, percent calf crop, okay, longevity of the animal, okay, these are all low heritability, okay, these are not passed, or these are not very heritable between the parent and the offspring, okay, so make sure and look at that chart and understand, kind of what that's talking about, okay. Selection methods, there's different ways that you can select for things, tandem is going to be one trait at a time. You can have really rapid change in a single highly heritable trait, but it's typically not recommended because if you put the blinders on and only focus on one trait, you can actually have other things kind of fall off the wagon when you're so focused on one. A more common practice is called independent culling level, and that's where it establishes minimum levels for each trait. Okay, so you keep multiple traits in mind or involved in your selection process. It's easy to implement. It can be done at various stages. Okay. This is an idea of kind of selection over the years. You can see that there's been some significant advancements in weaning and yearling weight. Okay, producing more pounds on that animal at weaning and yearling. But the thing that we were able to keep the same is the birth weight. Okay, so we were able to make huge advancements in more product produced without causing more dystocia problems or birthing problems by not increasing that birth weight. Okay, so then we get into the discussion of EPDs. Okay, and EPDs are an expected progeny difference. Okay, and it's a visual appraisal of the most basic selection process. Okay, and this will be our primary lab assignment, and I think Dr. Dooley will probably go through this with you in lab. But what it is it's breed associations have pedigree records for different animals, and it's essentially a performance database. Okay, and so you can take bulls or females and look at their EPDs and kind of have a numerical value help you make different selections on what animals you'd like to select for. Okay, so look at Moodle. There's going to be something from the American Angus Association on there that kind of goes down through the definitions of EPDs for the Angus Association, and then there is an assignment kind of assigned working with EPDs and looking at those. Okay, so that is it for this week.